It is my pleasure to introduce today's presenter, Connor Duhame. Connor is an energy systems specialist at Fast Track. He holds a bachelor degree in energy systems engineering and has been working in the solar industry for over a decade. Most of his career has been working on project management, project design, and support for solar racking systems. Without further ado, I will pass it over to Connor to get us started. Thank you.
Great. Thanks, Tatum. Yeah, thanks everybody for joining us today. We're excited to launch our new ground mount racking, the Fast Track Elite. So I'll jump ahead here. So for all of you familiar with our Titan Light racking, this is really an evolution, the next gen, if you will, of the Titan Light, and we're calling it the Fast Track Elite. So this is a fixed tilt ground mount racking solution. It has a very robust design. It uses our shared rail mounting to optimize bifacial modules, preset attachment points, and common hardware to make this really slick and simple. And really what you're going to see is, again, for those of you who are kind of loyalists or familiar with the Titan Light, that the format is very similar, but we have made some notable improvements and additions to the racking, largely driven by client feedback and feedback from the field as to what we need to do to make this product better and address the ever-changing module market and make this completely compatible and really bigger and better. So I'm going to go through, we'll dive into the details of kind of all of this stuff, but this is a high level overview, I guess, of our features and advantages of the racking system. So it's bifacial optimized. So we use a shared rail system on this rack, which is fairly unique in the industry. There's really not many doing this. And really what this does is it unleashes the power of your bifacial modules. So by using a shared rail, we're running those along the long edges of the module, and we're really minimizing backside shading. And by doing that, it keeps the backside as open as possible. So when you get that reflection off the ground and the ambient light, you're going to get as much extra generation as possible from the backside of this array. Although this is a fixed tilt ground mount, we do have a couple of tilt options available. So we have two out of the box preset tilt configurations, the first being the 35-degree tilt and the second being 45. And really, these are your two optimal tilts for pretty much anywhere in Canada. Sometimes one might be beneficial to another, depending on shading or snow shedding or things like this. And certain latitudes can have better performance than other. And there is no change in the BOM or anything. This just comes right out of the box, and it's just of how you install it. Effortless module attachment. So again, another unique feature of the Fast Track Elite is our back bolting. So because we use a shared rail, the modules, the long edge of the frame is going to sit right on those rails. And they use a roll-in clip, the same style we use in our Titan Light racking. And this allows us to use the bolting holes on the back of the module. And there's a couple of reasons this is great. The first is that it means we're always adhering to green zone clamping. So you never need to worry, you never need to measure. If you're bolting at those bolt holes, you are instantly compliant with green zone mounting. Secondly, they're self-aligning. And so it really makes it easy. You're not measuring, you're not spending time trying to figure out where those clamps are going to be. And the third and final really big feature is because it's back bolting, you're fastening these from underneath. So this is a big advantage. These arrays are quite tall. To be able to get on top of these and get a clamp and get your tools up, you really need a ladder or a lift, and you're getting pretty high in the air. So the ability to go underneath the array and have quick, easy access to the fasteners, it makes it really simple and safe. Layout versatility. So this is really one of the main, kind of design features that we've expanded on in this next gen of racking. So this, where we used to be locked into a couple of preset sizes, we now have an expandable design that really accommodates almost any quantity of modules. You can mix and match. You can fit what you need on the layout, and you can expand your legs. So we're not limited to 2 or 3 legs on the system. We can go wider to 5. And this allows us to fit a much wider range of modules and also be much more compatible. So because we're in landscape, the length of the module kind of dictates how many modules you can fit onto the rack. And by having these different options in the scalable design, we can fit really any count and make any module work. Reduced hardware. So we've gone through and we've really taken this thing to the chopping block and tried to anywhere we can remove a part, remove hardware, reduce the amount of operations. We've done so. So we're down to 2 fastener sizes within this system. We have 1/2-inch bolts for all of our main leg connections, and then M8 bolts throughout the rest of the system. And then finally, easy inverter mounting. We really see the full range of inverters paired with these systems. String inverters, very common, but also micro inverters. And we have options for both. We have mounting options, so you can put your string inverter right on the rack. And we have attachment brackets for your microinverters or optimizers so that you can fasten those anywhere along the rail. Yeah, so as I touched on, universal module fitment. And so really any common tier 1 module in the market, certainly everything we distribute is going to fit on this rack. The different module lengths will change how many can fit onto a rack. But generally speaking, your total kilowatts on, say, a 2-leg or a 3-leg wide system is going to be equivalent, whether you're using larger 600-watt modules or smaller 500-watt modules. Anything can fit. Okay, so I'm going to talk a bit about our configurable design. So this is pretty new, and I think a really significant improvement over our previous racking. So we've gone to really the scalable design. So we can go anywhere from 2 legs to 5 legs in length. And really it's just a matter of stacking on additional legs until you hit this 5-leg limit. We do have a structural splice as part of the system. So our splice, and I've got some details further on that we can take a look at this, but it's very simple and it's structurally rated, so it carries the full capacity of the rail. So it can be installed at the midspan of the rail. And that really just gives us flexibility on this 2-leg design. We typically would use a splice right in the middle. And it allows us to have, again, flexibility in laying out the rails. And you never know, sometimes you get into a unique situation, or maybe you're navigating some crazy terrain or some rocks or something like that. We have abilities to get creative and really find a solution for any project. Now, the reason we capped it at a 5-leg is due to thermal expansion. So really every 50 feet or so, and this really applies to any array, whether it's a ground mount or a rooftop, every 50 feet you want to have provisions for thermal expansion. And really what that means is a physical break in the array so that as the temperature changes, everything can kind of expand and contract and you're not going to have issues within the rack. And our 5-leg is kind of right at that sweet spot. So that's where we would be provisioning for a thermal expansion joint anyways. So by doing this, we cap it at the 5-leg. And then, of course, if you were going to do a longer row, you would install it directly adjacent. They can be right up close if you want, within a couple of inches. So it's more or less as a continuous array. And then you're inherently compliant with any thermal expansion. And it really makes it simple when you're not trying to manage that aspect of it. And then I've got some different pictures throughout, but I guess another feature here is depending on the length of the module, again, it's going to change how many can fit onto these arrays. So if you look at this 2-leg module, we've got 3 modules wide by 4 modules high. In this picture, this is a fairly standard kind of a 500, 550 watt module, but they can get longer than this. So if you're dealing with some of these new, mega 78 cell modules, they're super long. They can totally fit on this rack, but what it might mean is that you can only go 2 wide. and same with all these other configurations. So really, you're just going to add up the lengths of your modules, and as long whatever you can fit within the lengths of the rail, that's that's what we can fit within that system. And then the second one we can configure, and this is really a preset, is the tilt angle. So this is a fixed mount. And what I mean by that is you're going to install this full thing and it's not seasonally adjustable. So you're going to pick a tilt and then it's going to live like that forever. The ability to adjust it seasonally is really just not feasible in this design. It would be too heavy and too cumbersome to do. But you do have those two set points from the get-go. And really all this is a matter of picking the right connection point. You can kind of see in the little round image in the middle, we've got two marks. They are engraved, so you can very quickly and easily see which is which, the 35 and the 45. And that's where you're going to pin your back leg. So the back leg and the front leg are just going to connect with a pair of bolts. And you choose the 35 or the 45, depending on the tilt that you want. And then the second adjustment is the leg spacing. So as you can see in the image at the bottom, the kind of north-south spacing of the feet of the rack are wider or narrower depending on the tilt. So for the 45 degree, you're going to tighten those up and you're going to use the other set point. And with that combination, we are able to increase that tilt angle.
You want to take a moment and answer a couple of questions before
Yeah.
we go on, Connor?
Let's do it.
All right. Question from Eric Smiley. Are there any provisions for attaching screening or conduit to render the conductors inaccessible to the public? So,
Yeah, it's a great question. We don't have a product line to pair with this specifically for, covering the conduits or the wires. So yeah, totally understand that you need to have your wiring inaccessible to meet, electrical safety standards. So no, right now the answer is we don't have a kit or any kind of product that goes with this to accomplish that. I know installers are using a variety of different methods, whether it's, metal sheeting or, a wire mesh, that kind of thing. Now, what you do have that works, fairly nicely, I guess, is you're still going to need to come up with that solution. But you can attach things anywhere along the length of the rail. So I guess what typically would be done is the wires are going to route down to the side of the rail. And from there, you can fasten on whatever that cover is going to be. It can just kind of bolt on or screw on to the side of the rail and cover up your cables.
thanks, Connor. Another question also from Eric. Are the bolts just hex head type?
Yes. So the 1/2-inch bolts, and they're going to be all kind of your main pins that connect the main leg frame. They're just 1/2-inch standard hex bolts. They're hot dip galvanized, so they're corrosion resistant. But yes, nothing fancy about them. They're just a standard bolt. All of our other connections, and we'll see some better images, but really for bolting down the rails to the frame and then the modules to the rails, those are all going to be M8 fasteners. And they, again, are essentially a standard bolt, but we use a flanged hex bolt and a flanged hex nut. And really what this does is it eliminates the washers. So it's a few less steps when you're installing, less bits and pieces. And the flange hex nuts, they're essentially a built-in washer and they've got kind of a serrated finish on them. So they bite in, they provide, a tighter fit. They're not going to come loose over time from vibration and that kind of thing.
Thanks, Connor. That's all the questions for now.
All right. So foundation flexibility. So foundation's obviously a critical component for your racking. And we've designed this to be, it's really compatible with just about any foundation you can come up with. What I've listed here are what I would say are the 3 most common styles, but it's not necessarily limited. So the first being helical piles. So this could be a driven pile, helical pile, ground screw, really any kind of metal post that gets installed into the ground. So typically a screw pile of some sort is what we're seeing very commonly used. So the front foot of the racking, so you can see it here, it's just kind of this U-shaped bracket, and it has a couple of different mounting options. It does have a hole in the center that can accommodate 3/4 inch hardware. So you can pin that down with a single bolt. Some of the piles have got 3/4 inch studs on them. We've seen them attached directly to the stud. And then often really the mounting plates, I think, is the most common. So we don't supply anything from the foot down. Everything you see there, like a pile supplier is going to supply, of course, the pile and then the adapter bracket. So the most common that I see is that you can get these flat plate adapter brackets, and those just fit right on top of the pile, and they can be custom designed if you want, or you can bolt down directly to them or drill your own holes. There's all kinds of options, and I've seen a lot of different things done here. Secondary to that center hole is we do have 2 smaller holes for 1/2 inch bolts. And so instead of using that one large center bolt, you can use 2 smaller ones. Concrete piers, also a very common option. Typically a little bit more, well, a little bit less concrete than a big block. The reason being a concrete pier is going to go into the ground, usually at least 4 to 6 feet. That really depends on your site and the design. But because those are in the ground, they're going to get some resistance, and they can react to the loads better than just a big block. So they don't rely entirely on the ballast. So they can be a more efficient design. And then the third, of course, is just a simple block. And this can be done in a couple of ways. It could be a poured block. So you would form it, pour it, reinforcement inside. And then the second that we see used quite often is like precast concrete blocks. So if you think of those like large retaining wall blocks that kind of lock together, they're a great option, especially for small systems. You can order them in and just get them dropped. And really all you have to do is place them on site. So again, we're compatible with all of these foundation types. You can bolt down, you can use either of those hole selections. And for anything concrete, you can just standard concrete fasteners like an epoxy anchor, a Hilti anchor, those sorts of things are commonly used. Or if you're pouring it, you certainly could have a stud or a J-bolt kind of thing embedded right into the pad. And I guess another option that I've seen, maybe not a ton, but here and there, would be kind of custom frames. So sometimes like a wooden frame can be used, and sometimes that's in conjunction with piles or pads. So again, it's really versatile. Like you can screw this bracket, kind of the front foot down to just about anything. So if you care to do like a wood structure underneath, kind of a cribbing style setup, that's totally acceptable as well. So our shared rail. So this is really one of the highlights that makes our system unique. So by a shared rail, really what that means is that in between the modules, this rail is going to pick up a module on the left and on the right. So as you can see in the picture here, so it's got kind of a 2 flanges on either side. So the module is going to sit right in those flanges. And what's really great about this is when you install your rails, so you're going to have 5 rails high. Once those 2 rails are installed, your module will just sit right inside. So you don't have to worry about aligning or positioning. Of course, in the east-west direction, you're going to want to center your array on the rack. But really all you have to do is space these rails, and then once they're pinned down, the modules just sit into place. So it makes it really quick and easy. And one of the beauty of this is just the alignment and the aesthetics of the rack. You're pretty much going to be bang on every single time. If you can think of doing portrait mounted modules, like say on a roof or many other systems, one of the key things when you're installing modules on a sloped roof is to get that first edge perfect, right? That's the first thing you see is the first edge of the modules. And if they're crooked or if they're kind of out of alignment, it's going to make the whole thing difficult to install, and it's just not going to look nice at the end. But with this rail, because it kind of works like a channel, it's going to auto align your modules. They're always going to look perfect. And then the back bolting. So again, you can kind of see in this picture. So those bolts, they're going to go in through the bottom, and they use a little clip that clips into the rail from the bottom. And it's going to use the existing bolt holes on the module. So 4 bolts per module. And again, this is accessible from underneath, so it's very easy to get to. You're not trying to climb on top of the array or get onto really big tall ladders or leaning over, that kind of stuff. You just go underneath and everything is easily accessible. And your modules will literally sit in place while you're doing this because they're sitting in the rails. You don't need to have someone kind of holding the module carefully until you get your clamps on. Instead, you just place your module, it's right where you want it, and then you go in underneath and bolt it on. And then we use the same kind of clips to mount the rail to the leg. And so you can see that here, same fastener, same clip. So you're going to use a set of those for each of those connections as well. And really the only measuring you have to do here is your initial placement of the rails. And what is really common is to do, especially if you're doing a larger job, like where you're going to have a whole bunch of these racks, I would highly recommend coming up with a jig. And it could be as simple as a piece of 2x4 or a piece of wood, and cut it to the width of your module, and that's going to space your rails. And then so you can place that jig in between, do one on either side. And so you'll pin down your first rail, and then you just use those spacers to space your rails. So again, like really minimizing measurement, and it gets everything nice and square and simple. So it makes for a very fast and accurate installation.
Want to take a couple more questions, Connor?
Yeah.
I think both of these really relate to the previous slide.
Yeah.
Question from Sean Bell. Can you make the feet with 1-inch holes? All our screw piles are 1 inch and they have to machine them out every time.
So what we, I guess that's maybe what we did, isn't it, Stenko? That was our latest.
I didn't want to correct you, but I think we changed the design to a 1-inch
No, you're
slot
totally
in the
right.
middle from a 3/4, so it is 1 inch.
And that's what is a great question. So yes, it has always been 3/4 inch. And in fact, when we started this design, it was 3/4 inch. And we got that exact feedback that 1 inch is very common. So I stand corrected. The center slot on the foot is in fact for a 1-inch bolt. So yeah, I think you'll be happy to see that. And I think the feedback for that is the stud on top of the piles is very commonly a 1 inch. So it gives you that option. So yes, great question.
Second question from an anonymous attendee. Front bottom panel, what's the max height from the ground?
There's no hard and fast rule. So the way the rack works is you can see like this bottom rail, which more or less represents the bottom edge of the modules, is really quite low to the ground. So the ground clearance, you're going to get that from your foundations. So the height of your piles sticking out of the ground or your concrete, whatever it may be. So it's kind of up to you. The general rule of thumb is 1 meter or just over 3 feet. That's kind of the typical that I recommend. The two reasons I would give you that is one, for snow shedding. Throughout the winter, it is a slippery tilted surface. Snow is going to slide off. It's going to pile on the bottom. So you want enough space there, especially if you're in a snowy location, that you're not going to worry about that kind of piling back up onto the array over the winter. And then the second one is just like undergrowth. If it's out in a field and it's maybe not maintained all that often, you don't want weeds and brush and stuff like that growing up and shading. But again, totally up to you. 3 feet, 1 meter is very common, but I've seen lower for sure. And I've seen higher as well. So it all depends on your project.
Thanks, Connor. That's all the questions we have for now.
Great. Okay, so I'm going to go through a few of the components. So one of our kind of design initiatives was to, again, cut components where possible. We want to make it simpler. We want less connections, less pieces, faster install time. So really what we've done is simplified the leg connections. So the leg is really just a very simple triangle. You've got your front leg. That's really the main support for the whole structure. And then your back leg is going to bolt directly to that, and that creates this kind of triangle frame. And then at either end, you've got a foot. And so that's that small bracket that's going to allow you to fasten this down to your foundation. And all of those connections are just a pair of bolts, one on either side. So limited hardware, it all aligns very easily. So it's very quick, rapid installation. And then the rails, of course, so this whole substructure, I should say, is a galvanized steel. So it's very robust, really solid, designed for the Canadian environment. And then our rails are aluminum. So everything within the system is corrosion resistant. And one of the questions we get a lot is dissimilar metals between aluminum and galvanized steel. And for one, this is a super common combination, and they're fully compatible, and they're going to last kind of the lifetime of your project. So they're designed to pair together, and you're not going to see crazy interactions between metals. And furthermore, everything is corrosion resistant, whether it's the galvanized steel or the aluminum. So these are going to hold up over time, and they're not going to get all rusty and falling apart. They're gonna stand strong over the years, even on East Coast and salty environments. And then that's more or less it. So I guess the only other component is the cross brace on the back. So it's just a smaller steel beam, and it's going to make this kind of V-shaped pattern. And if you have more legs, that'll just kind of zigzag along the rack as you go. And this provides lateral stability for the mount. So really, again, like we've eliminated a couple of brackets, and we've certainly reduced the hardware from previous iterations of this rack. So faster install, simpler install. That's the name of the game. So to expand a little bit more on the rails, so this shared rail, we've been using this for quite some time. So it's not a new profile. The system is kind of proved and has been used, and some of you may have used it before. So that'll be very familiar. But what we have done, which I think is a notable improvement, is reduce the lengths. So we've limited to 2 different rail lengths for the system, a 120 inch, so 10 foot, and a 170 inch, which is just about 14 feet. So this is quite a bit shorter than the rails that we used to carry. So it's going to make it easier for shipping, handling, just dealing with on site. They're still long components, and they're designed for long spans. But overall, these are going to be just friendlier to deal with all around. The legs on our rack, they're going to be spaced at 10 feet on center. That's our standard spacing. So these rails are designed to accommodate that 10-foot span. And then they're going to overhang the edge by, it's just under 5 feet. And by the time you add the module on, it ends up being a 5-foot overhang off the side. Another unique feature is the rail configuration. So the reason we have these 2 lengths, the 170-inch rail is always going to go at the 2 ends of the rack. So the reason being, it's going to do that 10-foot span plus the cantilever. So that gets us to 170 inches. And then everything on the interior of an array, so say these longer ones, like this 4-leg system, for example, this inner bay, these are going to be 10 feet center to center. And then you're going to use a 10-foot rail. So what this means is the joints in the rails are generally going to land right over top of the leg. And what it does is this eliminates trimming. You've got the rails, they're all going to be just the right length for the rack. So you bolt them on and you're good to go. Because we don't want you spending a whole lot of time on site trying to figure out rail lengths, align splices, all that kind of stuff that makes an installation complicated. We want to keep it simple. So these are going to be just those standard lengths. And there may be cases like if you have a certain module configuration, it's possible for the modules to be a little bit shorter than the length of the rail, if you will. So in a case like that, for aesthetic purposes, by all means, you can trim off the ends of the rails. That's not an issue. But generally speaking, most of your installs are not going to require any trimming whatsoever. So again, it makes it very simple and easy to install. And then on the right, this is our structural splice. So we've made this again as simple as possible too. So it's a slide-in design. It fits on the inside channel of the rail. It has an integrated bond washer on the side. So again, everything within this whole system is going to be integrated bonding. It's all torqued connections, and on this rail splice, we're going to maintain that bond. And it's as simple as popping it into place. There's no fasteners, and it maintains the full structural capacity of the rail. Robust design. So as we got into this design of the Fast Track Elite, we really have kept in mind maintaining a robust design is really critical and is kind of part of our product identity. So we want this to be compatible anywhere in Canada, especially places like East Coast and BC, where you get really extreme wind and snow loads and all this stuff. Canada really is unique. We get very high loads. Not every rack is designed by Canadians in Canada for Canada. So really everything that goes into this design is for our climate. So we're proud to say this can go just about anywhere. It's really designed to hit all the key locations without any additional components. So you're not going to need brace kits. You're not going to need custom engineering. Our base rack is going to fit, well over 90% of Canadian locations. And really the few that might see any kind of custom engineering would be extremely remote, where you're likely not going to be installing anyways. Heavy duty steel frame. So again, the leg kit is super solid on this rack. You're going to feel it when you install it. It doesn't shake, it doesn't bend, it really feels solid. And again, the Typhoon rail is a very solid rail. It's quite a beefy profile. And by the time you bolt the modules on top, it becomes a very rigid frame. So, in the wind, especially out east, like we see hurricanes, things like this come through. This is a rack that's going to stand up and it's going to perform extremely well. And then tilt angle, like another benefit of having the different tilts, if you're in a really high snow load location, that's somewhere where you may want to do the 45-degree tilt. So having, of course, the higher the tilt angle, the better it's going to shed snow. So one, that's good for the rack structurally. Two, it's going to keep it clear for more of the year. So if you deal with a lot of snow and you want to optimize generation, as of course we all do, you're going to get a little bit better production, in those snowy regions by going to a higher tilt. And I guess lastly, it's this entire rack is designed in compliance with NBCC 2020. So that's our national building code in Canada. We have in-house engineers who, one, have done all this design work, and two, who can support your project. So if you're working on, a larger project and you need to have drawings done or approvals or reaction loads or any of that good stuff, we have the team in-house who can do this work, and we know this rack inside and out, so we can support your projects. So a bit of a comparison. There are a variety of different mounts on the market, all with different features. But I'm going to kind of go through maybe some of the highlights and how we compare. Competitive pricing. So although we have a very robust design and we've kind of tried to stick with that, that identity, we're not sacrificing costs. So we want it to be price competitive. So within the market, I think you're really going to find that it stacks up well, if not better than many of the competitors out there. So while you're getting one of the most robust racks out there, you're not going to break the bank. Optimal design. So again, this is really where we stand out. The shared rail, totally unique. So we're really trying to optimize generation, especially for bifacial modules. And really, I'm sure most of you have noticed almost all the new modules coming out these days are bifacial. It's slowly kind of becoming the standard. So why not get the maximum benefit out of those modules? And then 10-foot spans, again, by pushing fairly long spans, we can get your number of foundations down while keeping it, rock solid. Foundation compatibility. If I'm being honest, most ground mounts have wide range of compatibility. This isn't uncommon, but we've made sure that it's versatile, and really we tried to make sure that foot has a couple of different options in it. So you can choose to use the 2-bolt, you can choose to use the 1-bolt, and they're kind of standard spacing, and they're going to fit on a variety of different pile attachments, concrete, different anchors, all that good stuff. So it's very flexible and compatible with just about any foundation. Ease of installation, again, very fast. We've designed this to be minimal hardware, minimal measuring. Because it's a steel frame, all the holes within it they're pre-punched, they're preset. So you don't really need to measure like along a rail to try and get your things lined up. You're going to bolt it where the hole is. So it really takes the thinking, takes the measuring largely out of the equation, and that's going to help you install your projects faster and more accurately. Lead times. So we stock this locally across Canada. For most projects, we can, react to out of stock. Of course, if you're getting into larger projects like 100 kilowatt or greater, you're going to expect to have to order something like that in. We may not have stock available at that time. But to that point, everything here is Canadian made. Our aluminum rails are extruded in Canada. Our steel, it's all made here in Ontario, actually. So we can get the stuff fast. It's not big lead times to get the product in. So even if you're doing a large project like a 300 kilowatt and you need to order everything in, we can react to that quite quickly. And for typical timelines on a project, you're not going to have an issue sourcing the rack. Module compatibility, again, we can fit really any standard module on the market today. I'm sure there's a few really oddball things out there, but generally speaking, any tier 1 standard module is going to fit. Online tools, we've got a great website. We've got documentation on the website. We've put a lot of work into making that accessible for you. And on top of that, we've got an online calculator that I am going to spend a few minutes going through today. Our marketing team has done an amazing job making this really user-friendly, intuitive, and you can get bill of materials, help figure out your designs just through this online tool. Warranty, we have a 10-year limited warranty on our product. And technical support. So we have in-house engineers and we have the team, we have the knowledge, and we can support your project and do your engineering and all that good stuff. So I'm going to pivot here for a minute, and I want to show everybody the calculator. So what I'm actually going to do is pop out of here. This is just a screenshot of the calculator. But I'm going to go into my web browser. Hopefully that's working for everybody. So what I've done, I've kind of preset a bit of a demo system here. And now what we do is, so if you go to fastrack.ca, that's where you're going to find these tools. And under this resources tab at the top, well, for one, if you click on the download section, that's where you're going to find installation manuals and other resources for all of our racking. And then we've got these builders, and the one we're going to talk about today is the Elite Builder. So you can go into here. I've just put in a demo system project name, but you can set this to whatever you like. Maybe it's a client name or a project name. And then this drop down, you can select, we've got a long list of different modules on here, so you can put these in. We do have the ability to put in a custom module. So if it's not on the list, you can click custom and you can type in the length, width, those kinds of things. Inverter kits, so you can choose if you want to have the inverter mounting bracket included or MLPE mounting brackets included. Those are optional on here. And then this is really where the magic happens. So you can choose how many modules you want per array. So I've got this configured as a 16 module array. And it's as simple as toggling this up or down. You can see it populates it really nice, gives you a good visual. You can see if you get like weird in between sizes, you're not always going to have an even number. So you can do that type of thing. And then in a case where, say I want multiple, so I've got a 16 module array, but maybe I'm going to have 3 of these throughout my site, I can just toggle that up. So it's going to be, instead of 1, I go 2, 3, and that's going to go into my BOM. And then maybe I'm mixing and matching. Maybe to hit the module quantity, I need one more set of 8 modules to hit my target. You can totally do that. So you go in and you add another row. And I can do that. You can add multiple. I can do another one down here if you want. And I don't know if there's a limit. Somebody can test it for me, but I haven't found it yet. And then what this is going to do is at the bottom, you're going to get a bill of materials. So it's going to give you some system info, width of the system, how many modules, and then all of your components. So it's a really quick way to get this. And then you can take this, you can print it as a PDF or an Excel if you like, or you can email it directly to your sales rep and they can get you a quote. So it's a really quick way to get a bill of materials, get pricing, quickly size your system. And one more neat feature I wanted to touch on, as you're designing these, there's a lot of different ways you can configure the system, of course. And it's going to give you this kind of, I guess, notification to help you optimize. So what I've got here is I've got this 16 module array, which is going to have 3 legs on it. And then I've got an 8 module array that's going to have 2 legs on it. So I've got a total of 5 legs. But what this is telling me is that, hey, if you want to do a 24 module system, there is a way to do it with only 4 legs. That would be the most optimal design. So that's kind of cool because foundations, of course, are a really pricey part of the project. The less foundations, the better. It's going to save you money and time. So this will tell you that, hey, maybe I can configure this in a different way to reduce my foundations. And here it's going to tell you how many. So for example, we've got this 16 and an 8, and it's going to use 5 foundations. Now what I've built over here on the next tab, here's a single 24 module array, and you can see it's only going to use 4 foundations. So in doing so, you've saved a set of legs. So one, not only is that racking, you're going to save a little bit on the racking, but 2 on piles, like piles or concrete foundations can be quite expensive. So you're saving costs, saving time. Okay, I'll jump back to the presentation. Yeah, I guess lastly, so we distribute this through Charge Solar. And again, the benefits here, we've got nationwide inventory, we've got warehousing across Canada, Ontario, Halifax, BC, Edmonton. So really we can service you wherever you are. Technical support, again, we've got engineering team countrywide. We can offer quick turnarounds. We can do system design, support, whatever you need. We're here to help you with your project. And as well, we have everything else you need, right? So if you need modules, you need inverters, you need electrical engineering services, we offer all of that through Charge Solar. How to get our services. So typically to kind of go through the engineering process with Charge, we have an intake form. You can get these through the website. Of course, you can always just send through detailed info on your system, especially for the ground mounts. But what we're going to do is once we get your intake and we get all your system details, we're going to give you a proposal. So this will include the engineering quote, if you will, for the project. And that'll vary depending on the size and complexity. And then based on your bill of materials, which we can help you with, or you can do it yourself online through the tool, you're going to get a sales order with all the components and a quote on all the parts. So you've got your engineering quote. If needed, you've got your quote for all your materials. And then we can do sealed drawings. Generally speaking, like most ground mounts don't actually need a building permit or engineering. It's very common for that not to be required. But what you will usually need is reaction loads or some kind of loading so that you can size your foundations. So we can support with that. And then especially larger projects or for certain clients, if it's, I don't know, a government's installed or school board, or there are certainly cases where fully engineered drawings are required. So we can do that. And that'll include a full set of plans with layouts and foundation spacings and all that good stuff to help you execute your project. And then finally, once you've gone through all of this, of course, we ship out. And like I say, we're stocked nationwide, so we can react pretty quickly to that for you. That brings us to the end. So I'm going to leave it there, but I'm going to open it up. If there are further questions, or Stenko, if there's anything else in the queue, we can kind of go back and answer them as they come.
No questions in the queue right now. But maybe just to elaborate on how to get service fees, that's really if you require engineering services. You don't, if you're just looking to order material and install, that you can do that with the builder and you can do that with your account manager. This is really if you're looking for engineering support, this is how we provide it. And some of our service levels in terms of how quickly we turn that around. If you want an engineering proposal, we'll do that within 2 business days. And then if once you've signed off on that proposal, we'll get you a design within a couple of weeks or less. Still no questions. So again, if there's any additional questions, we're here to open them. We'll give it another minute.
While we wait for any last questions, Connor, thank you so much for joining today. That was a fantastic presentation, very thorough. If anyone has any questions at all, please feel free to reach out to myself at marketing@chargesolar.com or engineering@chargesolar.com. They can answer any questions you may have. Still no questions. Connor, you answered them all.
Wow, look at that.
Oh, here's one.
We got one. Is this ready to ship today? Um, So we are expecting our initial stock orders this month, and those will be landing in our Barrie warehouse this month, and then from there we just need to do some stock transfers. So it will be available in June for shipment out of Barrie and likely out of Calgary and Halifax, if not beginning of July at the latest.
Yeah, for sure. And if you're looking to quote something, depending on your timing, especially if it's something later in the summer or midsummer, we're getting very close to having that stock available, but we can help you start quoting it now. So if you've got a system in mind, by all means, send it through and we can start helping you get it organized.
Another question, how much this is from my good friend Ian, how much does the 35 versus 45 degree tilt change this shading distance needed between rows?
That's a great question. I don't know that I have an exact number off the top of my head. It's probably going to add another 10 feet or so in between. It depends what kind of shading you're comfortable with. Like that's kind of a trade-off that you have to think about if you have multiple rows of racking. Usually, like my rule of thumb is kind of a shade angle coming in. I usually think about around a 20-degree shade angle, but I know there's plenty of people who would space them more to absolutely minimize. So there's no hard and fast rule, I guess, but assuming you maintain equivalent shade, it's probably another 10 feet or so space in between. Really, the only downside to spacing out further like that is mostly wiring, right? If you're going to have things further out, you're going to have kind of longer home run cables, longer trenching, all that kind of stuff. But by all means, you can space these as far as you want.
Yeah, as Connor said, it depends, on your shade angle of desire, if you will, and where you are in the country in terms of latitude. But we don't, in terms of just purely geometrical differences for an equivalent shade angle and location, I don't think we don't have that pre-canned, but Ian, we can certainly calculate that for you.
Yeah, if you are on a tight site where you're, trying to squeeze in rows, then yeah, totally the 35 degree, you're going to be able to pack them in a little bit tighter.
Another question from Angel Garcia. Are they more expensive than previous designs? And if so, how much more expensive?
Well, I
So,
guess, you take it away.
sure. I think if you're comparing it to a Titan Light, I think the cost will be favorable on this system as compared to Titan Light. It's really a discussion with your account manager and in terms of how these are going to be priced for specific systems. But generally speaking, I think our pricing over Titan Light will be improved.
Yeah, and maybe to expand on that a little bit is Well, the frame is very robust and solid. One of the key improvements on this versus Titan is the Titan was only 3 modules tall, and this is now 4 modules tall. So if you think about for every set of legs, you've got that whole extra row of modules on top. So your total wattage per set of legs has increased. So while the steel and rails and all that stuff are, robust, we've gained a bunch more wattage per array. So the trade-off has been, in the positive direction, in fact.
Seeing any more questions coming in?
All right. Well, if there's no more questions, I guess we will
Oh,
end it. Oh, one more. I spoke too soon.
spoke too soon. One just came in from Carter James. Oh, not a question. It's a compliment. Thank you. Thanks, guys. Great presentation. Thank you, Carter.
Wonderful. Well, if there's no more questions, thank you again, Connor and Stonko, for joining us.